All right, sounds good. All right, let's do this. I'm a little nervous, so please excuse me. Let's see how we go. If y'all have questions about any of this, please feel free to interrupt me, and I'll try and answer them as best as I can. FYI, the PureScript compiler version we're going to be talking about is 0.11.7 because that's where I did all this work. 0.12 is out, which has a few different things in there, which I'm not going to be covering about. So actually, the code is easier to understand in 0.12. Anyway, so that being said, let's get started. So this is basically a story, I guess, of how all the troubles that I faced at work with regards to our Angular and mishmash of Redux and Redux-Sagas and other things became too much of a pain for me to follow mentally. And so it was just a story of like how I ended up at that particular point and then sort of the steps we took to get to using PureScript and Halogen. So the agenda for today is basically, we'll just briefly cover some of the challenges in working with the JavaScript application and scaling it. And then sort of how do you pick and choose what level of detail to build into your next thing that you're going to pick some new technology to do. And then we'll talk about PureScript and Halogen, sort of talk about a couple of neat things in PureScript and sort of Halogen, its architecture. And we'll talk about testing, because that's kind of important if you're writing any kind of application. And we'll just briefly touch on how to sort of introduce PureScript at work. And this very much, I'm so glad that this morning's keynote was about essentially how to introduce FP at work. So there's a lot of relating points in there. And I was like, all right, I can delete half my stuff, and that's not a big deal. It's great. All right, so on to challenges. This is not really a challenge. Having lots of existing libraries, that's totally great. JavaScript has a very rich ecosystem about that. However, the issue is that there's not really a good amount of common abstractions that you can easily share between various libraries and various frameworks. It all sort of falls over when you try and integrate all these different patterns. So just a simple example would be like, you have callbacks, you have promises, you have async await, you have generators, you have some sort of FRP libraries, you have observables, and just try making them work well together. It takes a lot of effort. And unfortunately, what was it? Someone said the other day that, it's nice not to have vendor lock-in, but when you're writing all this glue code, you are the vendor. And this is the only thing now you have to maintain. And the lack of types really hurts a lot in a really big application, or even in a medium-sized application, because now you have to, anytime you do any kind of context switching, you come back a week later, you have to reread a whole bunch of code just to get up to speed as to where you were. And that's a little, it takes too much time. Things should be easier. So onto our app. When I joined my team at work, they were already using Angular 1. something. We're still using Angular 1. something. And I guess it seemed like it's a good pick because you can't kind of go wrong because it has lots of really useful things in it that are useful for web programming. And their little tagline, however, it's interesting that it's a super heroic JavaScript model view, whatever framework. And that super heroic part really means you have so many different things now that you have to learn and learn how all these things work well together. And you have to understand all the Angular nuances in them. And if you try to write idiomatic JavaScript code, you're going to be fighting with Angular half the time and trying to figure out, oh, wait, I have to use a special array update thing because magically something in there has shifted underneath me. Angular by itself in a big application is hard to follow. The problem I guess we were having at work and my coworkers having at work is we had a bunch of different components that had lots of state that they would share. So for example, if there's a user profile in the top right corner, and there's a user's listing page, well, that same profile information is there. Or if you're editing your own profile, a lot of information is shared. And this is a very simple example. There's other things in there. So they were having trouble with that. And so we figured, okay, you know what? This thing called Redux sounds like a pretty good idea. As in you have events, you have a state, and you have reducers, and you all of a sudden have a new state, and we'll just plug that back into Angular. And that sounds like a really good idea. And it worked pretty well. And the nice thing about Redux is it kind of introduces you to sort of the FP world, where it sort of encourages you to just operate only on data and not a mixture of data and behavior. Like, for example, if you have a class that modifies its internals via some method, Redux sort of discourages you from doing that. The not so nice thing about Redux is you have to write a lot of boilerplate, just a lot, to get some simple things done. And by itself, Redux is synchronous. And what that means is like if you click a button and you update a state, that's not a problem. But if you click a button, initiate an Ajax request, now you need to bring in some sort of Redux plugin to help solve that asynchronous issue. So at first glance, when everyone picks up Redux, the first thing you hop to is like Redux Thunk, because that's like the thing to do. And the thing is, it works. It works. We'll keep it at that. The bad thing is it's all callback oriented. This is like you're writing JavaScript from like 1995. It's not that great. And composing callbacks is not a whole lot of fun. And testing becomes very painful, especially if you have any levels of nesting when it comes to doing callbacks. So that quickly went out of favor at work. However, we still have code with this in there because it's just so big, and it's who has time to refactor, right? So Redux-Sagas got brought in because it's like, hey, we can handle all this async stuff, but sort of write it in a very imperative manner, and it just sort of works. And for the most part, if you write all your code and meticulously go through each line by line, it works pretty well, not too bad. Unfortunately, the error handling is like really disgusting. It offers no help whatsoever if you mess up somewhere. Like if you've worked with Haskell and you think GHC error messages are bad, this one will just won't help you at all. It's not that great. And you have to write your code in a certain way in order to test some of the async stuff. You have to use like special function wrappers like call, and you're almost writing, you're familiar with function.apply and function.bind, that kind of thing. You kind of have to do something similar, but in the Saga way, to defer sort of actual calling of your thing. And that's only useful in testing. So you kind of have to do some weird things just to be able to test some things. And the asynchronous part that Saga solves is very nice. But when you have multiple sagas, and this is, I don't want to jump into too many details, but you can have multiple workflows sort of running in the background. And if you want to do any kind of interoperation between them, things become really complicated really quickly. And also bouncing between the sagas, but then also the plain Redux reducers. I hope you can see where I'm going with this, right? Like this is just too much stuff I have to deal with. So here's an example of an issue where I missed a keyword and I got this output. And the issue is on the 1, 2, 3, third line, I'm missing a yield in front of the select. Somewhere else down in my application, there's an error, and it all bubbles up because of this little bit. I'm like, if you're a generator and you're yielding particular statements, or if it's running this thing, I mean, put some development help in there at least, please, right? Like code I can comment out during production or use a development build or something. Anyway, so John Carmack has this to say about dynamic languages, and I'll just leave that as John Carmack's quote, not mine. And so the thing you have to do if you're living this sort of dynamic world is, while the world's on fire, you just have to say, I'm going to do my best, right? That's all you can do. So in our app, last I checked, we have about 25K of app code. Any guesses as to how much test code we have? 500 lines, okay. 15,000. 1,000. All right, that's quite a spread. So actually, we have 33,000 lines of code. We have more test code than our actual app code, because if you want to be correct in JavaScript, you have to do a lot of work, right? And I'm going to sidestep the issue of bringing in FP libraries because I think David's probably already done that earlier before. So we've tried. And it's just Angular is not happy with any kind of integration with sort of FP stuff in there. Because especially in the templates, it's awful. Don't try. Move on to React or something else if you have to. Anyway, so TLDR. JavaScript's difficult to scale because lack of common abstractions and lack of integrations between libraries that don't use any kind of common abstractions. And so you can't compose things very easily. You kind of have to go do it all yourself, and then maintain all that yourself. And when something goes wrong, you know that all this stuff is sort of fragilely held. And dealing with that is not a lot of fun. So I was basically sick and tired of bouncing through all the templates, all the services, all the directors, all the Redux reducers, all the sagas, and just bouncing back and forth between all these different things, I'm wasting my time. That's how I feel. So that being said, all right, fine, I want to move on to something else. I want to find another library. I want to find another framework. I want to find another language. What's a good criteria in terms of like picking something for work purposes to say, what's some good criteria for us to evaluate whether this technology or groups or pieces of technology are going to be helpful to us? Writing a to-do list is great, but it's not going to give you any indication of whether this thing, how it actually works in an actual environment, or rather in your environment, right? So the criteria is, first and foremost, it needs to be non-trivial. We wanted expressive data types that could sort of capture not only the data model that we have, but also sort of the UI state. We wanted to do some sort of data validation, see what that looks like. In Angular, it's not that great. Directives and functions, and just, it's not very nice. So we want to find a better way of doing this. And also do some sort of server-side interaction, XHR calls, and see get a feel for that as well. And also to kind of see what it would look like to sort of have a child component or two. Like if you build something just by itself that doesn't interact with anything else, I feel like that doesn't quite give you a good indication of some of the complexity that can arise. So we just wanted to include that in there as well. Eventually your application will somehow have to deal with some sort of global state. We have one use case for that in our application, and that's kind of about it, but it was important to at least see what these pieces of technologies offer in terms of like threading that global data all the way down into like the innermost component. And also obviously testing. How easy or simple or non-trivial or difficult is it, these new technologies, are they to test? So we've got this users page that admins can go to and like other people can go to. And you can there's filters on the right, you can sort of toggle them on and off, it'll change the view. As soon as you do that, you can search for users. The add user button shows up if you're an admin. And if you click that, we get this little component, which then if you hit submit, it'll try and run some validations on there. And the interesting bit in our application is that based on certain security settings, based on times and things like that, if you try to create a user, you might be presented with the login screen to say, hey, please re-authenticate, because this is sort of like a sensitive thing for you to do. And then when you're here, you kind of get taken back here. And then here you can finish your create user request, if you will. So this seemed to be a complicated enough feature. I don't like using the word component because that means so many things to everybody. Feature. Two features, right? One's the listing of the users and filtering them. The other one is creating the user. And the third one, incidentally, is related to the second one, which is re-authentication, right? Three things that we have. So I've got a bunch of experience in other languages. This talk is about PureScript. If we'd like to chat about why not X, let's leave that towards the end. So on data types, the first thing right off the bat that's kind of nice, it's better than JavaScript, is you have types, right? You've got some semblance of what this thing might be. So in this case, we've got email and username, they're sort of strings. User role is a string. And if you think about it for a second, user role, it's an admin, it's a publisher, or a viewer in our application. Having it as a string makes no sense. So you change it to a type with a sum type. So now you can actually represent this thing as different constructors, if you will. There's a role type there. So you might have an email and a username, but those are strings as well. And if you think about the possibilities you can do with strings, you can add them, change them, remove them, do a bunch of things with them. You don't really want that. So your initial inclination is, I'm going to give types to these things as well. And so now your data model on top has this int email username. Looks kind of nice. However, if you pass Bob, who's the username, into some function that operates on strings, it works just fine. The only reason is because the type keyword, going back a slide, is a type alias. I really wish that was more pronounced. It's a little bit of a gotcha, so don't don't use just type alias, like for usernames and strings. It's a little bit of a letdown there. So the way to do it is to kind of create a new type. A new type is basically a wrapper around your wrapping data model, if you will. Like, so for example, if you were to redeclare Bob over here, before it was, you just say it's a string, but now you have to put Bob in a data constructor, which is username. So now you can't easily go change the contents of a username or an email. So now it's sort of fixed. So the interesting bit is, like, you can kind of use this to construct new types. So you can say, give me a string. I might create an email out of it. Maybe I'll give you an email back. Maybe either there'll be an error or there'll be an email. And you can sort of hide that implementation, so the user is never able to modify the inside of the email. You just not expose that constructor to the user. Anyway, that's another side thing you can do. I'm not aiming for this to be like a tutorial on PureScript or a tutorial on like Halogen, but you should be able to get the gist of like how things work and compose well. If you have questions, please, like I said, stop me. So the nice thing in PureScript is the compiler can actually derive a whole bunch of functionality for you. You don't have to write equality instance, for example, over here. You can write it by hand, but you don't have to. You can just tell the compiler, hey, just give me an equal thing, because it knows enough about all the types to just generate stuff for you, which is really nice. Sometimes you may not want that. So for example, I've declared this over here, right? If you want to compare whether an admin is greater than the user, in whatever sense that makes, you can tell the compiler to give you an ORed instance. But now, is admin less than the viewer, or is it greater than the viewer? Right? The compiler-derived instance doesn't really know. Right? It just has a particular way it does things. So this one, you're better off writing by hand, being more explicit about it. Other things you can do, by default, you can't really print your data types in PureScript unless they have a show instance on them, because PureScript doesn't make any assumptions about what does it mean for me to print your data type, like, or to be able to show it. It makes no assumptions. So you can, again, just tell the compiler, hey, just give me an instance for it, please. You derive generic, which is a sort of like a type reflection. You can think about it that way, where it knows some metadata about your types. And then you can say, hey, with that metadata, give me this show functionality, because someone else already implements it for me. Don't squint too hard, don't worry about it. So on to data validation. So for our, back up a slide, like, so as far as our data models went, it was very expressive in terms of like being able to just use types everywhere to describe what we had. In JavaScript, when we had services and things that wanted to find out, like for example, is this role greater than the other role? You have to write a whole bunch of, you have to write a function around it and pass a bunch of strings around. Passing strings is error prone, so you have to have tests for everything that you write. Hence the 10,000 more lines of code that we had than our actual application code. So data validation is actually pretty easy. How many of you went to Joe's talk yesterday? All right, like 10% of you, maybe 20%. So a really quick recap. In PureScript, the sort of the way we end up doing our data validations, we just have like a sum type of all the various errors that our application can possibly produce in that create user screen. And we just sort of have, in this case, we need to display it to the user at some point. So we just pattern match and just tell the user, hey, this is the string that represents this particular data type. Easy enough. Now comes the fun part about composing or actually doing all this validation together, right? So in PureScript, there's a nice little library called PureScript Validation, which I'm pretty sure that's what Joe used yesterday. And this validation type is called V. Not terribly helpful, but we end up declaring our application as a type alias. So our validation type, if you will, is either a non-empty list of errors, or it's a result. And the result is just whatever you're trying to validate over there. And the way you sort of use this, for example, like we have an isEmpty validation. So if this thing is actually empty, then we'll throw an error, or we'll give you an error saying, hey, this thing is actually empty. If it's not, then we just say, whatever you originally had is totally fine. We'll just keep going on with it. To couple this with another validator, so it just sort of looks like this. We just say, is the empty this input? And then you sort of combine it with the invalid email test, the invalid email validation. So in this case, you're just sort of combining the validations together. You're running one after the other, if you want to look at it that way. And sort of what you get at the end of it is you build up these validations into even more validations. So for example, over here, if we want to validate an actual user with all the different like first name, last name, email roles, etc., we run all their validators for them, and then we sort of combine them into this record that's up on line 3. And then ultimately at the end of the day, with the type signature, we're left with it's either a non-empty list of validation errors or it's a create user request. So in PureScript and sort of the Haskell world, maybe generalize it to MLE world, is that you try and sort of have these building blocks, and those building blocks just keep building. And you can sort of wrap more functionality around them, ultimately till what you actually need. So this code does look very terse, and it is written in a particular manner, but that doesn't preclude you from using the actual, like all these little type operators that are over there. You can actually just use their actual names if you want to as well. You don't have to use the particular operators there. A lot of people get scared off from that, and that's totally understandable, but there's an alternative way to write that if you like to. Any questions on this? All right, so we found validation to be super easy because it's just a few things, and you just combine those few things and you're done. And now it's completely reusable across your entire application. None of it's sort of hard-coded into a particular component that you forgot to refactor. It's great. So for routing, or not for routing, sorry, for XHR and doing Ajax interactions, PureScript, Elm, and yeah, just PureScript and Elm that I know of. And if you write JS on the front end, which is weird, if you're using PureScript and Elm, interacting with the server requires an extra step. And that extra step is you have to parse the JSON into your own type. In PureScript, that step looks pretty easy with this library called SimpleJSON. SimpleJSON uses generics under the hood to just sort of say, hey, you gave me a record, or you're telling me what type this record is supposed to translate into, and I'll just try and do it for you. So that's kind of about all it looks like in using SimpleJSON, which is really nice. Like, you don't have to do a lot of work. It's great. Compared to Elm, this is so much nicer. And if you want to go from a type to a JSON string, it's actually pretty easy as well. You just say, here's my record, and just give me JSON, and it dumps it into a string for you. Super easy. Yeah. Those booleans are just values for the keys that are there. I should have, sorry, that second example is incorrect because those quotes should be all gone. The double quotes should be gone there. Does that clear it up? Just think that the double quotes aren't there. Because it's just a record that you're passing to write JSON. So this is easy enough. Easy as calling JSON stringify or JSON toString, or parse, I guess, yeah. If you go down the route that I did in trying to investigate how to use actual generics and like just doing this kind of work, you end up with this library called PureScript foreign generic. And foreign generic is interesting, but don't use it. Like, at least not for the 0.11.7 compiler, the package that matches that. Don't use that. You have to work around a few things, and it's weird. Like, you'll see in the JSON that's up there, I have to put my type in a particular manner. I have to say the tag for this is authentication settings, and the contents is this record of things. Whereas in the previous slide, I didn't have to do any of that. I'm just like, hey, just take this JSON, give me the authentication type, and it just works. Over here, it's, like I said, try not to do that. So if you go down this route, don't use this library for doing JSON. There's a simpler way to do it. The route that we ended up going, however, was actually PureScript Argonaut, which is a very manual parsing library. we have to do this because we have a bunch of different JSON keys that come back that are quite not normal. They have underscores, some of them are smashed together, so there's no, like, if you're writing a PureScript record, I kind of want to keep my PureScript code a little cleaner than what the JSON looks like. I don't want to have the same keys, so I have to do some manual translating over here and just passing what the keys possibly might be. But that is a way to do this. So given a JSON object, which you get from the next library we'll talk about, how can I produce my own type? In this case, doing this parsing manually will give you your type ultimately. Either that or it's going to be an error that it's going to give you. And to go the opposite direction, to encode stuff, you do something like this, which isn't too much work, but still work. I'd rather just get free things from the compiler. Nothing wrong with that. Any questions so far? Okay. So if you're trying to understand some of this code, I'd recommend you try not to. Right? The point of this talk isn't necessarily to teach you the internal details or the details of how to write these things, right? Each one of these topics could be their own talk. The point of this is to show you what the analogous equivalent is, or the equivalent is, in sort of the PureScript world and in Halogen, and sort of build it together and see how these things are slightly better, far better sometimes, than their equivalents in the Angular Redux-Sagas world that I came from. Doing Ajax stuff was pretty easy. PureScript Ajax is generally the library to use. The way we sort of went about it was we described all our possible errors that we could possibly have in our application first, because some types are awesome. That's all I have to say. Some types are great because they let you model all your different states that could possibly be there. So once we sort of had this, we said, okay, the next bit to do is kind of create a generic function that says, hey, given the actual response from the server, and you give me a JSON decoder, I'll take those and run them and produce either an error of XHR, an either of the XHR error or the type that you actually want, right? Because we have a few different, the implementation of this deals with the re-authentication part. So if a server sends back a particular type of message, we want to tell whoever called us, hey, your request didn't go through, it's actually a re-auth error, do what you need to do again, right? So we have to reflect that property back up to whomever called this function. So that's why we kind of say, just give us a decoder, give us a response, and we'll give you something back. That's either the error or some value that you want. And the way you sort of just call this is you just kind of do this. The avar line over there, I'll skip that for a second. The next bit that goes Ajax and default user requests, those just kind of do the actual calls to the Ajax. They interact with your server. This should look sort of familiar like jQuery and all the other popular libraries that are out there that wrap all the XHR stuff. It's pretty simple. The avar stuff, that's the interesting bit, is that we actually have a XSRF token that's reflected in type. So when you're making requests, we always have to pass this XSRF token down. And during re-authentication, this XSRF token can change. So that's why we have this avar. And avar is similar to basically a global variable, if you want to roughly think about it that way. But it's reflected in the type system. So we know that this thing is a mutable thing that we have over here. And so we have to just sort of pass it down to whomever ultimately needs it. And you're kind of doing a very manual form of dependency injection, which is just a big fancy word for pass me the argument. Right? And so we just basically pass these things down, and whomever ultimately needs to use it, they end up using it. So that's why this thing's got avar.read avar. It's like, hey, go get this thing and try and read the contents of it. There's some interesting semantics around there, like if two people try and read the same thing, that might be okay. But if one person's trying to put some different XSRF token, but someone else is trying to read it, the read's going to block if the write's happening first. So there's some of those manual things you might do For example, like using semaphores and things like that, you don't have to. This avar library or this avar type takes care of that for you, yes.
So when we talk about Haskell in more like traditional sense, we have pure functions and we have IOs and we try to separate out our side effects from the things that don't have side effects.
Sure.
And if I'm going to call an API of some sort,
yeah,
there's text from my application that's essentially side effectful.
Sure.
Whereas it has the potential to be.
Yeah.
How do you designate or do you not designate in PureScript
sure.
which portions of your application have
IO and which ones don't?
Not like the IOs and everything else.
Right. So you see that last line that's there that says XHRE, and then either whatever. That XHR type, if you will, is sort of the effecty part. That function represents, that says, I'm going to run and give you back the result contained inside this XHR type. And for all intents and purposes, our XHR type is this bottom bit right there, which is just a type alias for AF. And AF is the asynchronous effect monad in PureScript. So this is where you can do threading, you can do semaphores, you can do communications between multiple coroutines, you can do asynchronous effects, for example, like Ajax, things like that. This is, for all intents and purposes, your asynchronous I/O, the AF is. Does that answer that? Okay. Any questions? If you have questions, please ask, because otherwise, like, it's just silence is slightly. Oh, which lights? Oh, these are.
Let me grab this for you.
Oh, great.
How's that? Just so that I still see my name.
Cool. Yes, you had a question?
Oh no, I'm just checking the video.
Oh, I thought Jonathan back there also had a question. Oh, okay, all right, cool. Okay, so on to Halogen. So Halogen, I compared it sort of with Pux and a couple other things that were out there. I decided I didn't really want to be back in the Redux world, so I chose not to use Pux, and because Pux is a wrapper around React, and you're sort of supposed to use it with Redux. I didn't want to do that because of my bitter experience, I guess. So I just chose Halogen, and I was like, hey, this kind of looks kind of cool. I was like, let me go take a stab at it. And so it turns out Halogen is actually pretty nice. We'll kind of go through sort of Halogen, sort of the architecture around it. It's pretty interesting. The interesting bit in Halogen, each component can have their own, each component can have a state for itself. It doesn't require global state, which I think is kind of nice, so I can just reason within this one context. I don't have to think about the world around me, which I can be focused. I like that part. And you can nest multiple components, and you can communicate bi-directionally between the components, but you can only communicate one level up or one level down. That restriction I find to be quite nice, because usually that's what you need. Usually, most of the time, you don't need to tell some component all the way up that, hey, this thing happened. And if you want to, you can actually manually thread all that up if you need to. So Halogen's interesting in the sense that well, let's just go through it. So in Halogen, each component can have an input data type that sort of kicks it off, that says, hey, here's some input, initialize yourself. Right? For in this case, it's like, here's the XSRF token, here's a couple other things for you. And then, since each component has its own state, we can take that input and sort of build our own internal state. And so our state now includes the XSRF token, that username validator, and a couple other things that are relevant to that component. So in this case, it's just some form data and some errors related to that form. And a general error is just something we need, which is something broke. Where do we show that? So once you have the input into your component, you generate your state. And along with that state, you have to declare what are known as a query algebra. For all intents and purposes, if you are accustomed to Redux, these are sort of your actions, if you will. These are the possible things that your component needs to care about. And in this case, it's just all four of them are DOM events. But the first one's interesting in that it wraps another query. It's recursive, if you will. And that's just saying, if I click a link, for example, it's going to call prevent default on it, and then it's going to call the next query associated with it. So in this case, I use it for the form submission, which is prevent default on the form submission, and actually go then do the submit form action. Good? All right. So now that we have a state and a query, the next thing for us to do is to use that somehow, right? So in Halogen, there's this notion of an update function. It's called eval, but we'll call it update over here. And update, all it does is basically drop you into this world where now you have to deal with these queries that you had before, the actions. And you handle the actions and you update the state. You basically modify whatever internals you need to based on the actions that you just received. Right? So this is your reducer, if you will. But the reducer also works in an asynchronous mode, which is awesome. It's way better than a bunch of other stuff that's out there. Because you can do Ajax requests and everything in here with do notation. It's pretty nice.
Would you write one of these for application or one per?
One per component, yeah. So each component has its own input, state, query, update function. And once this update runs initially and keeps running, the view is invoked. The view function will, the render function, which is just, hey, I have my state. How do I then take my component state and display that to the user? So in Halogen, you just kind of use a DSL built out of functions to represent your HTML, so very similar to what Elm does. And in there, for example, you'll notice in the onSubmit and the value change stuff, you can basically say, hey, on these events, go dispatch those actions, that query that we ended up writing before. Right? So this is how your view can trigger those actions there, which will then call your update function again. That little loop that you see from the view to the query. So that's sort of the root of Halogen, if you will. That's sort of how it works. There are a couple other optional things you can do. Remember I mentioned the bi-directional communication? Sorry, Alex, yeah.
The queries, is that implemented in terms of standard browser event system?
So the queries over here, this is just some type of your descriptions of what you want to happen. And over here in the view, yeah, like for example, we have he.onValueChange. Those are all DOM event triggering functions, if you will. Right? Those are where you would say, for this particular DOM event, I want this action to be dispatched. Cool. So with the bidirectional communication, optionally your update function, and I say optionally, it can raise a message. And the way you sort of raise that message, you have to create a message type for your app, for your component, and then you simply call raise with whatever constructor you have. So now your parent component will then have to deal with it. It's very simple. It's kind of nice. And the parent has its own sort of life cycle, its own sort of component life cycle that it has to deal with. And a view can embed other child components as well, which also, again, have their own sort of life cycle. And the child components, the way you embed that is in the parent component, you have to, in your query, you have to create a special handling case for it and say, hey, how do I handle my child's messages, right? Because when your computer receives this query from the child, you have to handle it somehow. And so then in your update function, you just add another sum type that just handles that, and then you just do what you need to. So. And in the view part of it, actually putting your child in there, you have to use what they term a slot in there, which is just, hey, how can I take this other component and nest it inside my view? And that's simply kind of how you do that. It's pretty simple over there. That login input that gets passed to the login.component is just the initial input that we saw back in the diagram. So you kind of go back to stage one, if you will. All right, so you'll notice that all these little inputs and queries and everything has all these little letters that are right next to them, right? And I've color-coded all these different things up here. And all these have a particular meaning, which is reflected in Halogen's sort of generic type component. If I'd shown you the type component first, you would freak out and be like, what the hell is going on? Because there's way too many type variables that are in there. But all the type variables are reflected in that diagram. These are all the different pieces and components that are just reflected in the type system itself. So when you're looking at Halogen code and you're trying to figure out what a component can do, you can just kind of have a glance at it and be like, oh, that's what this is doing. So the thing I haven't talked about is the M, right? The last type variable that's over there. M's missing up in that diagram. And M is simply the monad under which this component sort of runs. And that monad in PureScript 0.11.7 is this row type, which I don't want to explain, which basically says, I'm somewhere where I can do Ajax, I can do DOM effects, and I can handle all these avars. Ultimately, that's what it is. In PureScript 0.12, it's just effect. That's all it's called. There's none of this Ajax DOM, none of this stuff that's in there. So, and sort of kick off your component and to start it, you basically, this is how you sort of initialize a component. For example, over here, I'm saying, hey, here's a parent component. Here's the initial state, and I've got a function that takes a state, the input, and produces my own state. So I've just tagged that over there. Render eval, and then receiver over there is interesting. Oh, sorry. In that the receiver is a function that takes a query and then sends back a maybe. It takes an input and returns a maybe of a query. And the receiver is useful for if your parent component sends you additional input messages besides the first one. So then you can sort of choose to handle it over here. And if you choose to handle it, your update function will be triggered every time that input comes through. But over here, we're just saying, I don't care what anyone sends me. I'm just going to ignore it after the first time. Good? Awesome. Thank you for the feedback. So embedding Halogen Angular, this has to be like the biggest letdown in my life because it's just so simple. Sorry.
Before we get into that,
Yeah.
if you have a tree of components,
Sure.
you have a component over on one side of the tree and a component in the other.
Yeah.
Is there any way to share state? So if you make an Ajax request,
Sure.
how do I put that in?
It'd be via explicit messaging. So like this one would send a message up, and then the parent can send a message down to the child.
Gotcha. Okay. So
Yeah.
that's good.
Has to go up, traverse that way. Yeah. You could sidestep it and create like an avar somewhere else with some FRP thing. Don't do that. Start simple.
With Redux, they go after the idea of a single global state.
Right.
I assume. And so when you do that, you kind of make the Ajax request somewhere else, put it in the global state, and then
Sure. This doesn't do that.
have any of that.
Yeah, this is just component-specific state.
I see.
Yeah. So embedding Halogen is like super trivial. I was surprised at how trivial it was. You basically find an element in the DOM, and then you just call run UI, and like that's kind of about it, which is pretty easy, that last line over there. The couple other lines I have before are just setting up that avar, if you will, and getting some cookie value. The JavaScript side of it is super simple as well. You're just like, hey, here's an Angular component, import the PureScript code and just call init. And that's it. The rest is Angular boilerplate. So integration is really simple. In this case, this PureScript component that we created is sort of self-contained. It doesn't really need to talk to the Angular world. But in case you do, here are a couple of slides. So in Halogen, that run UI actually returns a particular type. We used void before to ignore it. And that IO is basically a record with two functions in it. The query function allows other PureScript code to then send messages to Halogen. Remember how I said like there's a receiver, and if you get additional inputs, you can handle it? That's what this query function will sort of pump input messages down into the top level parent component. And subscribe allows other code to receive messages. Yes?
The slide before it,
Yes.
why was straightforward integration a letdown? What did you mean by that?
I thought it would be more complicated. That's all I thought.
That's awesome.
But it turned out to be so simple.
That's great.
Yeah. So over here, the query, you can use other PureScript code to send this component messages. And the subscribe, you can have Halogen raise messages, right? Your component can raise a message, and then some other code can receive those messages as well. So for example, the routing mechanisms, if you look at some of the PureScript routing libraries, they use, or you can leverage these two over here in order to plug into the routing system. So when the route changes, your code can then send a message to Halogen saying, hey, the route changed, go do what you need to. And Halogen can do the same thing. It's like, hey, my user clicked this, go change the route. So you kind of use this up and down messaging to do what you need to. And if you want to talk to PureScript, to JavaScript, it's super awesome because the FFI is like super easy. The nice thing to do, all you do is for an import and you create some function definition. And in this case, I'm trying to read a cookie from the document. So in this case, I'm just going to pass the just constructor down to my JavaScript function because I don't want it to reach into PureScript. I just want to pass all the dependencies down to my JavaScript function. And the JavaScript function pretty much just looks like this. And you'll note that all the calls are curried because that's how PureScript functions are. They're all curried by default. So now that you have those two things, you can just call them from wherever, but ideally you should just kind of create a little helper function. I just call a cookie value and I pass the requirements in. Yeah, exactly. So that's FFI in PureScript and JavaScript. The interop is super easy. It's not very complicated, and I really like the fact. Because sometimes you do need to do other things than just doing PureScript-y things and Halogen things. Sometimes you do need to invoke other JavaScript functions, especially when you're integrating your application and have it do other things outside your responsibility that your component has. When you're trying to migrate, that's very important. And to be able to have that in an easy fashion is very liberating. All right, we've got a little less than 15 minutes, so I'm going to try and get through this really quickly. Testing is super easy. Because majority of your business functions or business domain related functions should all be pure. I think there were like 2 talks talking about layers last couple of days, which is basically you have your externals, you have some internal application effecty things, but then all your business domain stuff should sort of be pure. An example over here is just we're decoding some stuff which isn't really businessy, but you can imagine that you have a business process that's actually modeled and you can test things over here. The test library I ended up using was PureScript test unit, which is really simple. Coupled with basic sort of unit testing, you get quick check as well. So quick check is kind of nice to just create invariants and test your functions to basically assert that those invariants hold with your function. In this case, the tests aren't that great, but the point is to sort of get the idea across. Where the first one is just saying, hey, give me some integers that are greater than 0 or greater or equal to 0, and just assume that the decode int function can decode that. The show variable, like we basically cast it to a string, where we create a string out of it, and we're saying the decode role should generate what the original thing was, or give you back what the original thing was. Questions about this? I did run into, I don't want to say an issue, but I was trying to sort of model how to test the Halogen components themselves. And this sort of the way you have to end up doing that is to kind of use a free monad. That's not a lot of fun. That's one of the down things I find, but it almost to me feels like if you're testing the Halogen component itself in terms of all the interactions it can do, like Ajax calls, and assume that Ajax calls call the right thing and do the right thing, you're sort of bleeding into integration testing at that point. And that to me, it's like, well, you can just sort of capture that with Selenium. But I would like to also follow through with that free monad and end up testing that as well. So if you chat to me afterwards, let me know. I'll put my email address up there, bug me about it later, and I'll come up with, I'll do that. Sorry, I don't have that code right now. The nice thing in PureScript, the tooling is amazing. Pursuit is sort of the hackage equivalent. where you can just search for types, search for functions, and it'll tell you, or search for types, and it'll tell you which functions match those types, which is really awesome. PSC package is the package manager. It's roughly, the nice thing about PSC package is it has this concept of curated package lists, similar to what Stack and Stackage do, which is interesting. PSC package is not quite Stack, but hopefully the analogy holds. PSC ID is a sort of a command line tool that automatically watches your code, recompiles it, and shows you any errors that are there, which is really helpful to have. The editor integration is just amazing. Autocomplete everything, which is awesome. You can just partially type functions and hit tab, and it's like, hey, which one of these do you want? It's really good. It's really good. Type holes are an interesting little language feature, where if you put like a question mark, you add some label to it, and you say, hey, what goes here? And it's like, hey, you could substitute your what thing with one of these functions. And the function list is longer than that, but I hope the point gets across, which is kind of neat when you're developing things. You're like, hey, what should go here? The compiler is really helpful in letting you know what other things are here. The things where I kind of go meh on are basically, if you're writing FFI with PureScript, and there might be a way around this, you're kind of restricted to like ES5 sort of level, or basically whatever level your browser ends up supporting, unless you use something like Webpack or Babel on top of post-processing all the PureScript output. So until then, you have to write like standard, not up-to-date JavaScript, I guess, which is not that big a deal for me, but for some people it might be. Embedding more than 2 child components in Halogen gets a little, I don't want to say tricky, but it involves a little bit more work. You have to use the either type, which is like not just for 2 type variables, but ones that can be constructed for n type variables. Look at the documentation. It's explained very well there. I'm not going to do a great job. I'm just going to butcher it. And the things that kind of make me sad are the docs and terms that are used sometimes can be unfamiliar, because they're not scary, they're just unfamiliar because they're just things you haven't encountered before. And there is lots of documentation outside of sort of the PureScript world on this terminology, but finding it is sometimes a little, I don't want to say tricky, but it's out there. You have to do extra effort and put in more work to kind of go look at these things. The docs in the PureScript ecosystem, they're not that great. We had Finton had a chat about it, or we'll talk about the Haskell sort of world and documentation, and I feel like the same sort of thing applies in the PureScript world, where we can be doing a much better job of it. PRs need to be raised. People need to ask questions like, hey, what the heck is going on here? How can I use this? Although if you look at the test directory, you can kind of get a pretty good idea for most projects. They usually have somewhat decent test coverage, especially so in the core libraries that are maintained by sort of the PureScript community and just the PureScript group. Like, tests are always there in any of those packages. But if you look for third-party packages, they might not be. So you might have to like bug the author about them. If you're going to introduce PureScript at work, don't go at it alone. Do not do that. I don't recommend doing that at all. It basically invites yourself to like being alienated from the rest of your team. Even if they know that you're working on it, don't do that. Involve other people in your work. Because ultimately you want to learn, but you also want other people in your group, in your teams to learn as well. So go at it together. PureScript does take some time for you to learn, especially if you're coming from basically non-ML world, if you don't have previous Haskell experience. There's a lot to unpack in there. So go at it at your own pace. This isn't an npm install, create my web app in 2 seconds. It is not that. So be prepared to be disappointed in that with that regard. I would highly suggest you join the PureScript community Slack channels. They're on FP Chat. If you aren't already there, I'd highly recommend that. There's not only PureScript stuff that's there, but also Haskell, and any kind of FP topic that you're interested in is on that Slack. So thank you. The company I'm working for is RStudio. The interesting bit, tiny little pitch for my company is I was given the time to explore. I could take my time and look into this as basically as much as I wanted to, without, obviously, I had to meet deadlines, but I had time to basically say, hey, this is okay for you to go explore and see what these things look like. That's about it. So there's a couple of books in there. The first one, one of the authors is sitting right there. The second one is written by Phil Freeman, who's the initial author of the PureScript compiler, and that book I think is pretty good as well. But you kind of should read both of those in tandem, or maybe finish the first one and then start the second one. And the example getter products I put up here are sort of like reference examples, if you will, of how to use certain libraries. So the first one deals with a couple of nuances around this Ajax library and sort of what are some of the gotchas you run into. And the author of that talks about how to sort of go about solving that. The second one in there is just a Halogen library. The docs folder and the examples folder you should really go through. The examples are really good. The docs are pretty good as well. And that's sort of how I end up learning Halogen, and also posting a bunch in the PureScript channel on FPChat. The third one is a nice little demo put together by someone, which basically shows how to write more complicated things than I have in Halogen. So if you want to learn what sort of the next things to look at might be, that's a good reference example there. And Nate has a fork of Slam data right before it was taken from open source into closed source that you can look at for additional Halogen sort of related help if you want to, or as a reference. So those are really good for that. Thank you. And questions? Yes.
I'm actually very curious about this transition experience from JavaScript Angular to PureScript. How exactly did you accomplish that? I mean, did you manage to actually get people on board in advance? Were there people on your team already interested?
People were already sort of fed up with how much work they had to do. So looking for something different that could help us solve it was definitely like high up on here. As far as the percentage of like where we're at with this integration, this is the only component to sort of get there. And we haven't merged it in, but it's still being tracked because we've decided that for this year, we don't want to introduce anything new. We just want to focus on getting additional features done.
But you all together decided to pursue it?
I did. That's why I said, don't go at it alone. Learn from my mistakes, please. We actually...
In our case, we feel the pain of lack of types. And the solution, I don't want to say our solution, the solution that we're using is Flow.
I see, yeah.
And it's like hard sometimes to come up with, I mean, it seems like every problem that crops up in the JavaScript application, you try to solve it by like stapling a new tool onto it, and then you create more problems.
Yeah.
And Flow seems like this better than nothing kind of solution, and
Yeah.
it's hard to get people to think of changing language ecosystems entirely when you have a kind of
You get a crutch.
I mean, using Flow feels like eating Mexican food in Germany.
Yeah.
It's not better than nothing. It's just,
Yeah.
You know, it doesn't feel like a very good experience.
It's not. I've used Flow in production, and I won't use it again. But that's been my personal experience. It's just the compiler's buggy. There's a whole bunch of hidden features that you have to enable by reading their repository. Things aren't very well documented, and subtyping JavaScript in general is just a pain. So like you can't create idiomatic JavaScript and then use Flow on top of it. Like if you want to do prototypes, if you want to do any kind of advanced JavaScript stuff, Flow is going to make your life a living hell, basically, because now you have to model all that complexity in the type system.
Yeah, I mean, I found this trying to do some validation with a library called Folktale. I don't know if you've heard of it.
Yeah.
It's pretty decent. I think it's based on Scala. And I got a good enough solution for validation. But then I had to incorporate Flow, and it just isn't compatible with Flow.
Right.
So then I just had to throw it out.
Yeah, if you want to write anything other than Redux and reducers, using Flow or like TypeScript even, they're not a good solution for writing. Like if you want to take the full power of JavaScript and really use that, these two things fight you all the time, constantly. That's been my experience.
It's just hard to make the case.
Yeah. The case for us is we have so much code that we're just bouncing around in all the time, and we don't know what the heck is happening, that doing something typed and something rigid almost, like in Halogen, you can't invent your own UI framework. Like, you just can't. You'd have to fight it tooth and nail in order to do that. And I find that kind of rigidity helpful. As in, you can't go outside these boundaries. Like, you must stay within these little tracks, basically. That I find to be very beneficial, especially on 2 teams that we have to deal with on this application. Like, this shouldn't be this hard. Like, doing this stuff should not take so much time. Some people don't want to take the pain, though. Sorry. Yeah.
You mentioned before that creating 1 and 2 child components is a pain in the ass. I wonder, because we want to create, like, usually we want to create components like more granular components,
Sure.
and we end up like with a lot of them. So
Ah.
what's the solution to that?
So in PureScript, or in Halogen also, let me go back to this little diagram thingy up here. All this stuff represents a component. Typically, most components that you end up creating don't usually want to do most of this stuff. Sometimes you just want something that renders HTML, and you kind of give it the actions of what to send back. So you can write very generic view functions that sort of capture like just a pure function almost, that basically says, give me the inputs, I'll construct something for you, and you can use it wherever you need to. So you write sort of generic looking view functions. Like example over here, where'd it go? Over here, the view state, like the type for this view right now is sort of fixed to my query type for this component. But if I replace that with like an A, now you can use that from elsewhere. That's all. Yeah. And if I pass those queries actions down as arguments, now I can construct something that's reusable elsewhere. Yeah.
The answer is more generic.
More generic code. More generic code means way less code. less duplicate stuff, yes.
So I know about Nate's Slam Data fork. Is there anything else fleshed out like that beyond what's in examples or tests on PureScript?
Unfortunately, no. There's not a big reference example. Like in Elm, at least they've got this something that Richard Feldman, I think his last name is. Like he ended up creating like this somewhat complicated SPA app that's in there, and with Elm, which I think is a good reference example. I think the Halogen world sort of needs, or a lot of the PureScript libraries do need something like that as well. Yeah.
Thank you.
Yep. Yes.
Yeah, sorry if this came up earlier.
No.
How do you handle file uploads?
How do I handle file uploads? I haven't run into that yet.
Yeah, like I recently managed to sneak Elm in
Yeah.
at work, so you was messaging all over, and then
I see.
using Elm ports with JavaScript.
Gotcha.
And then sending messages back.
This FFI is way easier than Elm stuff. Ever will be. At least not ever, but at least for the near future. The FFI here is much simpler and much nicer to work with. So if you need to jump out into JavaScript, just do it. PureScript does not discourage you from doing that. It's like, hey, we didn't build this, sorry. Open a PR, do it yourself. Like, enjoy.
And there are also cases where you are using a UI framework,
Sure.
like CSS framework.
Yeah.
And they also have some JavaScript components to initialize.
Sure.
So it's good to have that.
Yeah, and there's an example, so there is quite an example of wrapping the ACE editor inside Halogen. So you can basically effectively treat that ACE editor as a Halogen component, which I thought was pretty neat. That's on the Slam Data repo, I believe, as well. So you can check that out. And the Try PureScript website uses that, and the source code for that is open source. It doesn't, yeah, you can take a look at that. It's lunchtime. You can hang around and chat with me. Go get lunch.